Okay, so the first thing that this factoring flow chart asks you to determine, the very first thing, is there a common factor? And you're going to ask yourself that question on every single problem. So before we start working a problem out, using this whole flow chart, the first thing I want to make sure you understand is, what is the greatest common factor? Okay, a greatest common factor is going to be a common, well, let me rephrase that. It's going to be a factor. Now remember what a factor is. We did that in the last video. A factor common to all terms. Okay, what is a factor? A factor is a number that you multiply. So let's start off with something super easy. Let's do 2x plus 6. Okay, now this is a binomial, and at this point, it doesn't matter if it's a binomial or a trinomial, or if there's 4 terms or 5 terms. It doesn't matter. If you're going to factor, your very first job on all problems is to see if there's a greatest common factor. So you don't have to actually do everything that I'm writing down. You don't have to do it on paper, but you do have to do it mentally. So it has to be done, whether it's done on paper or whether it's done um, in your head. It doesn't matter. But I'm going to take this 2x and I'm going to write it down as 2 times 1 times x. And then I'm going to take this 6 and I'm going to write it down as 2 times 3. These are the factors of this first term. These are the factors of this term. And I'm looking for a factor that's common to all terms. Okay, we'll deal with the greatest part right here. First of all, a common factor is a factor greatest to all terms. So I look right here and I say, okay, this term has a 2, a 1, and an x. This term has a 2 and a 3. So what do both terms have in common? The common factor right there is a 2. So you write the 2 down, and then you open a set of parentheses and you write down the terms that were left. So right here, you're going to write down the 1 times x because it was left, not including the 2. This 2 and this 2 come here. Okay, we just write 1, 2 down, and then we're going to write what's left. The 1x and the 3 are what's left. So this is an example of factoring out the greatest common factor. I'm going to deal with the greatest here in just a second. I factored out a 2, and the 2 is now factored out. Notice right here that they say write it as GCF and then parentheses the quotient. So you think of factoring kind of like you think of division. I basically divided each term by 2. I brought the 2 out. I a lot of times I think of this process right here as the process of undistributing. This is not a mathematical word. This is a Burkett word. I'm really bad about making up my own words when I don't know of one that satisfies, the situation. So undistributing, I undistributed a 2. I looked up here. I noticed that this term right here had a factor of 2. I noticed this had a factor of 2. So I undistributed the 2. And when you undistribute the 2, it leaves you x plus 3. Okay, which is exactly what I have right here. Here I'm just showing the factoring, the steps of writing the factors down and then pulling out the 2, the common factor. So I don't care how you think about it. I don't care any about that. I just need you to be able to do it, okay? And be able to talk about it as a greatest common factor. Now, let's do another one. Let's do let's do 12x plus, I don't know, 18. Okay. Again, I picked a binomial. This is example 1. This is example 2. I picked a binomial, and you may see real quickly right here that, again, I can factor out a 2. I can undistribute a 2. Okay, so if you can say 2 times 6 times x plus 2 times 9. Okay, this is the factors of this example right here. These are the factors, and then the 2 is what I have in common. So I'm going to undistribute the 2, and what was left was a 6 times x, and what else was left? That was a 9. So I undistributed that 2. Now, the 2, it is a common factor. 2 is not the GCF here because it was not the greatest common factor. So if you go back and you think about this, yes, 2 times 6 is 12, but you can factor that 6 into 2 times 3. And the same thing is true about that 9. 2 times 9 does give me 18, but 9 is 3 times 3. So this right here, 2 times 2 is 4, 4 times 3 is 12. 12 times x is 12x. 2 times 2 is 3. 2 times 3 is 6. 6 times 3 is 18. So this is completely factored down to the prime factors. And the reason that I want to show you this is because I've got a common factor right here of 2 and a common factor right here of 3. Let me see if I can get some colors here. Here's a common factor of 2, and then here's a common factor of 3. So that means that I can bring the 2 out. This 2 can come out. And then I can bring the 3 out. And then the part that's going to be left inside was this 2 and the x and this 3. Those are the parts that were left inside. So when I close my parentheses, 2x was left inside and 3 was left inside. What I now see is that this problem 6 was the greatest common factor. And that's why we say use the word greatest, GCF, and not just common factor, because I can pull out a common factor, but usually the purpose of pulling out a common factor is so that I can do so many of these other things. And if I don't pull out the greatest common factor, then it's like I haven't even done there's no point in pulling out a common factor if I don't pull out the greatest one. Pulling out the greatest common factor is going to be required before I can do some of these other steps. Okay. Now, did you have to go through all of this process? Absolutely not. A lot of you will be able to see from the very beginning, oh, this is 6 times 2 x, and this is 6 times 3, and you'll be able to see that 6 is going to be the thing that's going to come out. And if you can see that, that's great. I mean, we get the same answer either way. But if you're not sure and you have to do it in pieces, then that's the way you do it. You get the prime factorization. These are numbers, these don't factor anymore. The only two factors of 2 are 2 and 1. The only factors of 3 are 3 and 1. Those are prime factors. So they don't factor anymore. So we don't have to worry about there being some other hidden common factor. All right? So you want to pull out a GCF, a greatest common factor. That's always step number 1. I'm going to do, I'll start the next video with the greatest common factor on a trinomial.